So 5.4 requires us to answer this question. For which values of x will x multiplied by the inverse, or not the inverse, but the first derivative of x be greater or equal to 0? So we need to see what our graph looks like first of all. So let me jump back to our function which we drew. In this case, this is it. So 5.4, which is the question we're on, says for which values of x will x multiplied by the first derivative of x be greater or equal to 0? So we're looking for when f multiplied, or the first derivative of x multiplied by its relevant x value, is greater or equal to 0. Greater or equal to 0. So we can divide this basically into two sections. We have on our graph the y-axis, which helps us to, let me rather highlight it. We have this y-axis, and at the y-axis we see our values changing for x. So over here we can just move this a bit so that it goes on the line, because I want to represent two different regions on our function. So we have this region on the left hand side, which represents x is less than 0. So this is x is negative, then this is x is greater than 0. Then if we look at our graph itself, we need to remember that the first derivative represents gradient. If we look at the gradient of this graph, it will always be positive, because from this side of the asymptote, we see the asymptote at 1. From the left hand side, our graph is always increasing like that. And also here from the right hand side, we see our graph is also always increasing. If we were to draw a tangent at any point on our graph, it will always be positive. See, drawing any random tangents gives us a positive gradient. So we know that this will always be positive. But x can be both negative and positive depending on which side of the x-axis we're on. So it can be both negative when x is less than 0, or it can be positive when x is greater than 0. So the thing that controls this inequality is x, the value of x that we're on. And basically we want it to be such that this will be negative x, this will be positive x. For us to meet this condition of multiplying these two and getting greater or equal to 0, we need to either multiply two negatives or we need to multiply two positives. That's the only way we can have them being greater or equal to 0. But in this case, we don't have the ability to make the first derivative negative since it's always positive. So this one is out of it, and then we consider this one. So this equation will only hold true when f of x is positive, of which it's always positive, and when x is positive, or which is positive when it's greater than 0. So this will be our answer. Only when x is greater than 0 will this inequality be true. So there is our answer over here.